All right, for number 4, this is a piecewise function. So remember with piecewise functions, we have, just like we did in our warm-up today, we have 2 different problems coming in from either end of this breaking point. What's the breaking point in this example? 2. So we have 2 different functions coming in from either end of 2. We have one coming in from the left, which is less than 2. This is a linear function. And we have one coming in from the right, which is greater than 2. And this is a quadratic function. So just remember how in our warm-up today they didn't meet? All right, in that case, the limits would not be equal to each other, therefore the limit would not exist. So we're going to check to see whether or not these actually meet at 2 or if they have a break, just like our example did this morning. So do you remember how we checked to see whether or not they meet? Yeah, we take the breaking point and just plug it into both of them. The reason we can do that is because we're not getting an undefined answer. So notice that if I plug in 2 to the first function, if I plug in 2 to the second function, I'm not getting anything that's undefined, which is okay. So if I plug in 2 up here, I get negative 2 times 2, negative 2 times 2 plus 6, what's that? Good, negative 4 plus 6, so 2. And if I plug it into the bottom function, I get 2 squared minus 1, what's that? 3. Are these equal to each other? Then the limit does not exist. So the answer choice is E. So because the limit from the left is not equal to the limit from the right, then the limit does not exist. And this would look very similar to the one we had this morning where there was a break in the graph and you had to take your pencil off the paper in order to get up to the other point.